Thank you for giving us about a half hour of your time this morning. IDEX Health and Science has supported this conference for going on about 6 years now, so it is great to see not only the conference grow, the site change every year, but the room continue to fill up. So thank you, and thank you to Jeff and Select Bio for putting on the conference. This morning we're going to be speaking about reagent management, which is an important topic for many of our customers, startups, as well as large OEMs that come to IDEX Health and Science with challenges as a transition from assay development through to a commercialized product starts beginning into their development cycle. But before we start, many of you may be familiar with IDEX Health and Science. Some of you may be familiar with some of our brands that we have collected into a large organization. So IDEX Health and Science is a global corporation, part of the IDEX company. We have about 1,000 people across 11 different sites globally, and we serve products and engineered solutions primarily in life sciences applications, ranging from life sciences tools, analytical instrumentation, as well as IVD applications, both core lab and what we team point of care diagnostics. About 1,600 OEM customers, so if you probably know them, we've probably worked with them. And in many cases, the folks sitting in this room, I recognize a fair number of our current customers. And the organization is split into 3 groups. Our optics organization, which covers life sciences applications. Our fluidics organization, which covers typically system-based fluidic components and subsystems. And then, of course, the reason we're all here today, which is the microfluidics and consumables group, which is a collection of 2 facilities for IDEX, a facility in Wallingford, Connecticut, and an acquisition that IDEX made roughly about 2 years ago, a company that many of you may be familiar with, Thinks Microtechnology, which is in Zweibrücken, Germany. And both of those 2 companies together, those 2 sites, form our portfolio of microfluidic solutions and technologies. When you think of a system and when you think of a development project, oftentimes a systems-based approach is really what enables success. And really whatever the project or the product is, IDEX tends to take a systems-based approach to speaking about that project or that solution or that customer. And so we tend to think of ourselves as an optofluidic company. And that's kind of a term that we've coined. But basically what it means is that when you look at the optics of a system, when you look at the fluidics of a system, and when you look at the microfluidics of a system, with microfluidics being at the nexium, everything has interdependencies both at an assay development, instrument development, and cartridge development that must be compensated for and balanced. And so when we think about a system or we think about a problem, we always kind of reflect back to this optofluidic pathway in order to solve and address those questions. So today we're going to talk a little bit about reagent management. And when customers come to us, the conversation always starts with workflow. And so let's take a simple workflow here today, a simple PCR workflow. So you have some level of sample introduction, you have some level of cell lyse, whether that's on card or off card. You look at purification, amplification, then you're looking at labeling, and finally detection. And so when we sit down with a customer or an OEM to discuss whatever design they want to look at, we typically start first at their workflow before we even pull out CAD or we even discuss about pre-existing design. And it starts with the assay workflow. And then the other thing that we look at almost exclusively is functionality and scalability. We have a number of customers that come to us having breadboarded or prototype a design that has gotten them through a couple initial rounds of seed or Series A funding. And unfortunately, those designs aren't scalable for the markets that they're looking to penetrate. And so when we speak with a customer, we always start not only with functionality, but scalability as well. And today we're going to talk about a couple different features and technologies that we offer to OEMs that are founded in scalability. And so they provide the functionality that customers and assay developers are looking for to manage the reagents, but the scalability not only at the prototype level, but all the way up through the millions of units, provide scalability to provide a solution to the market. And so we think of that as an assay and reagent plan. And we will sit down with an OEM to discuss what their assay is, what their workflow is, what specific card design inputs and outputs we have. Finally, the storage and shelf-life concerns for the assay and the market they're going after. And finally, scalable delivery. As I mentioned, everything we do in a prototype level is based upon a scalable manufacturing environment that's been founded at one or both of our facilities. So as we think about a workflow step, we start thinking about sample type, we start thinking about sample introduction, and that will relay in an assay and reagent plan over to what specific type of sample, what specific type of reagents are you looking at? What's going to be the introduction? Are you going to wind up using a swab? Is it going to be pipette? Are we going to be using large pipettes, small pipettes? And the assay. We work not only in immunoassay as well as chromatographic, genomic assays, as well as sample prep in life sciences. And what we're going to speak about next are really the on-card wet reagent and on-card dry reagent capabilities and technologies that we offer in that scalable environment. Once you have those reagents on card, you have to distribute them. They can't just sit around doing nothing. They have to interact. And so we look at the distribution of those fluids inside the card, as well as reconstitution from lyophilized reagents all the way up to mixing and detection. One of the questions we always have from our customers is that sample prep side and the reagent prep. What is the workflow going to be prior to an instrument or prior to that on-card reagent management? And we have a number of different clinicians actually having worked for our organization that have been in the lab space, whether that's been a research lab or a clinical lab, that provide a sense of end-user experience and consulting along with our customers to understand what the real applications of sample to answer or sample prep assays look like. And finally, when we look at that assay workflow, we think about the detect and what is going to happen to the management of those fluids after detection has happened. Is there going to be on-card waste? Is there going to be off-card waste? How are you going to manage the waste associated with the assay? And so oftentimes customers come to us with a fluid diagram, and this is a chromatography diagram that speaks to the complexity of an instrument. And we sit down, we try and lay out the fluids, the management of those fluids, and in some cases the dry reagents in a schematic that will end up looking like a card that can be commercialized. And so here you see a couple different features that we'll speak to next. We'll speak to sensor integration through reagent plugs, which is a core technology of our dry reagent handling, as well as in-card well management for bulk on-card fluidics. So fluid storage always discusses both shelf life and distribution of that fluid or reagent. Not only is mixing a concern, but separation and stability of on-card reagents becomes a concern as well. And one of the technologies we often speak with is what we call reagent well design. And so these are molded in-card wells that are capped with a polypropylene film. And then they are broken using a frangible seal design. And shelf life becomes a concern for many of our customers. And in this case, this graph shows stability of reagents across a basically 2-year period. And so within the limits of detection, the stability of those reagents and therefore the evaporation of the reagents inside the well is less than 1%. And what you'll see is that provides storage conditions in a fluid state and for customers that are understanding how that assay is going to predict over time. Second thing is the distribution of those fluids. And so frangible seals are a technology that we use that have mechanical actuation inside of the box that will break and then push fluid through a specific well. And the repeatability of that is critical as you're working through your assay and workflow discussion. And so this is data that we've collected over a number of samples, looking at a 200 microliter volume showing the stability of those seal distributions. So as a frangible seal is broken and then fluid is displaced, we wind up with very repeatable fluid distribution through that channel. So when you combine the two together, you can wind up putting an assay's wet fluidics into an environment that can be stored as well as distributed in a repeatable way. Many times we get customers looking to understand the aspects of dry reagents, lyophilized reagents inside of their cartridge. And so we've developed technology that allows simplified storage, reconstitution, and scalability of handling dry reagents. And it's focused on shelf life stability, primarily because dry reagents provide that stability in many assays, and the scalable operations not only at the reagent level, but also at the card manufacturing level. Our customers often try to look at scalability at manufacturing of the physical cartridge and don't have a good appreciation for the manufacturing of lyophilized reagents upstream to that manufacturing. And so our technology is a technology founded in what we call reagent plugs. And those are small injection molded plugs that are provided in an SBS well and sent to reagent manufacturing, where liquid reagent is deposited on top of those plugs and then dried. And you wind up with an array of what we call RPs, or reagent plugs, that have dried down reagents. Those reagents provide scalable manufacturing upstream to ensure that you get the most cost out in your reagent deposition. And then through automation and insertion of those reagent plugs inside of a cartridge, as you can see here, deposition and then insertion of that reagent plug inside of the cartridge, you wind up with scalability at the card manufacturing level. And what that does is it allows dried down reagents to be inserted inside of a mixing chamber so that wet reagents upstream in an assay from a molded reagent well can be created in an environment where mixing happens on the spot. And so what we find is we have customers that are looking for different volumes of reagents, different volumes of both dry and wet reagents. And so changing the physical properties of the reagent plugs as well as changing the layout of the fluid wells enables an environment where you can provide almost immediate mixing and immediate assay performance in a very small space. And what we sit down with in our customers is really a product roadmap. In many cases, customers are coming to us with a single assay looking to go into market. And we will almost immediately ask them, what is your follow-on product? Scalability not only of a design in manufacturing is important, but scalability of a design for product lifecycle is important. And a perfect example of this is a customer of ours, Protein Simple. We will sit down with a customer and understand what the current workflow is, but what is the future workflow? What is the next product so that you can provide scalability to that next generation of assays and next generations of products? In this case, using membrane valve and membrane pump technology, Protein Simple was able to use their Simpleplex Ella platform on an initial 16x4 design, and using the same core technology, scale that to 4 follow-on products over about a 2.5-year period. They were able to move that to a 72x1 platform, then 32 sample multiplex by 4, and then a 32 sample multiplex by 8 analytes. And then finally, and most recently launched, was a 48x1 environment that allowed customers to self-develop their own antibodies. And so when we speak with customers, we want to understand not only the workflow, what the scalability in design and specific functionality is, and then finally we look to understand how to manage those designs for future products and extensibility of their platform and product roadmap. Thank you.